Class 9, we are going to discuss Chapter 9, Weathering. So, in this chapter, we will know the meaning of weathering, its types, effects of weathering, physical weathering. In physical weathering, we will know about block and granular disintegration, exfoliation. In chemical weathering, we will know about oxidation, carbonation, hydration, and solution. And biological weathering, which is caused by humans, plants, and animals. So, the internal forces operating in the interior of the earth are described as constructive forces because they lead to the formation of landforms on the surface of the earth. Some forces also operate on the surface of the earth. They are known as exogenic forces. Exo means outside. These external forces act on the surface of the earth through several processes such as weathering, mass wasting, erosion, transportation, deposition, and formation of soils. These forces derive their energy from the sun. In all these cases, climate acts as the driving agent. Weathering is the process of breaking down of rocks but not its removal. It is described as disintegration or decomposition of rock in size by natural agents at or near the surface of the earth. It is so called because the disintegration or decomposition of rocks take place only by being exposed. It is the change in weather conditions like temperature, moisture, precipitation that disintegrate or break down the rocks. Weathering cannot take place on the moon's surface where such conditions do not exist. The footprints left on the moon by astronauts will last for millions of years. Thus, weathering is the basic process and an essential phase of denudation as described. Chief characteristics of weathering. Weathering involves disintegration or decay of solid rocks. It depends on climatic elements and on the characteristics of rock. For example, the rock's chemical composition, hardness, texture, and its permeability. That means allowing water to penetrate. Determines the weathering pattern. Weathering affects the surface of the earth. Weathering causes formation of soil. Weathering involves not one but several processes to cause disintegration of rocks. Weathering changes hard massive rocks into finer materials. It prepares rock materials for transportation by agents of gradation. Types of weathering. Weathering is a static process. The disintegration of rock may occur through physical forces, chemical forces, or by roots of plants, animals, insects, etc. Weathering is of three types: physical, chemical, and biological. Physical weathering is also known as mechanical weathering. It involves rock disintegration without any change in the chemical constituents of the rock. The factors responsible for the mechanical weathering are the extremes of temperature, nature of rocks, structure of rocks, frost, wind, slope of land. The extremes of temperature. The sandy, arid, and semi-arid regions are heated intensely during the day and lose heat rapidly in the night. Hence, the diurnal range of temperature is very high. This causes expansion of rocks during the day and contraction during the night. This causes rocks to disintegrate and split. Due to changes in temperature during summer and winter, and in case of arid region during day and night, causes expansion and contraction in the rock surface. This leads to breaking up of rock or peeling up of rock. Rectangular rock blocks thus are gradually rounded by splitting away of sharp corners, and this process is called exfoliation. Nature of rocks refers to the composition of rocks. Some rocks may be hard and some soft. Some may be soluble and some may be insoluble. Hence, the mechanical weathering takes place in the softer or soluble rocks more easily than in hard and insoluble rocks. In case of sandy soils of desert, it is picked up by wind more easily, while clay or loam cannot be lifted by air easily. Structure of rock. The texture or arrangement of the rocks also affects the process of weathering. For example, the vertically arranged layers of rocks are more susceptible to weathering as air, water, snow, and frost enter through gaps as compared to horizontally arranged layers. Once the water or frost enters the rocks, it starts its erosive action and breaks them into pieces. Frost is the most common agent of weathering in the temperate regions. When water enters the rocks and turns into ice, the volume increases. During the day, the ice thaws and the water enters deep into rocks. When temperature drops during the night, the water again freezes, widening the cracks. This repeated freezing and thawing results in breaking up of rocks. The wind blown sand particles attack the rocks and erode them. This is common in deserts. The rocks have different composition and structure. Hence, some portions of the soft rocks are easily eroded by action of winds, whereas the hard rocks remain exposed. For example, mushroom rocks and zeugans. Slope of land. Weathering also depends on the gradient of slope. The steep slopes of the rocks are eroded more rapidly by the agents of weathering as compared to gentle slopes. Block disintegration. The sudden rise and fall of temperature causes expansion and contraction of rocks. The repeated action causes their breakdown. At night, the temperature suddenly falls and during the day it rises suddenly. This leads to tension and splitting of rocks known as block disintegration. Granular disintegration. Since rocks are made up of different minerals, weathering may also reduce rocks to pieces and fragments. This type of disintegration is called granular disintegration. It may also take place in cold places and at high altitudes. The cracks and joints of rocks are filled with water during the day, and at night the water freezes, leading to rupture of rocks on account of repeated actions of melting and freezing. This is called frost action. Chemical weathering. The decomposition of rocks is called chemical weathering. It involves the breaking down of rocks by altering or dissolving the rock mineral due to chemical action or changes. It is more common in hot and humid regions. It is slow process as compared to mechanical weathering. The gradual decomposition of rocks takes place due to exposure to air and water. For example, water containing oxygen from the air may change iron into rocks to iron oxide or iron compounds. The process of chemical weathering is governed by the following factors: oxidation, hydration, carbonation, and solution. Oxidation means reaction of minerals in rocks to atmospheric oxygen. The rainwater also contains atmospheric oxygen. On coming in contact with iron compounds in the rocks, the iron starts rusting or crumbling. The color of rock also changes to red, yellow, or brown. Carbonation. Many mineral constituents of rock, such as carbon dioxide, while coming in contact with water, produce acidic effect on rocks. This action dissolves most calcareous rocks such as gypsum, marble, and limestone. However, this action should not be mistaken for solution. In the case of carbonation, rainwater converts calcium carbonate into calcium bicarbonate, which is soluble and is taken away by the groundwater. Hydration. In this process, Expansion of minerals occurs on coming into contact with rainwater. These minerals become heavy and start disintegrating. This action, though can be termed as physical or mechanical, its effects in hydration is a chemical process. Rocks like feldspar are converted into kaolin. Solution: it is the process in which minerals in the rocks dissolve in water. All rocks are subjected to solution to some extent. The rate at which solution takes place is affected not only by the mineral composition of rock but also by its structure. For example, sedimentary rocks have pore spaces between the grains in which air and water can lodge and thus attack the rocks. Some rock minerals, such as salts, are more soluble in water than others. For example, rainwater causes chemical disintegration of rock salt and gypsum. Biological weathering. It is also known as organic weathering. Its main agents are animals, insects, plants, and man. In all cases, however, both physical disintegration or chemical decomposition are involved. This is because all biological matter is made up of oxygen and water, the two substances that set off reaction of minerals in rocks. Humans, man is the most active agent of both physical and chemical weathering of rocks. For example, mining, excavations, construction of roads, buildings, etc. cause physical disintegration of rocks. Agriculture, dumping of chemicals and waste underground promote both physical and chemical weathering. Plants, roots of large trees reach deep into the rocks and cause physical disintegration due to pressure. Most of vegetation, however, prevents disintegration of rocks because it binds the surface layer and does not allow exposure of rocks beneath to the elements of weathering. Animals and insects. Animals like rabbits, worms, moles, and insects bring large quantities of fine material to the surface. Burrowing animals help to loosen the surface materials around the rocks, facilitating their physical disintegration. Upon death, the decaying animals also provide many chemicals and acids for rock disintegration. Effects of weathering. The decomposition and disintegration of rocks brings about a lot of changes on the Earth's surface. Its effects are both constructive as well as destructive. Constructive effects. Weathering leads to soil formation, which is required for agriculture. The weathering process leads to exposure of new minerals which become easy to be exploited. For example, chemical weathering gives rise to many new minerals having economic value. Weathering may provide new landscape, for example, karst topography. Weathering may provide building materials like cement and limestones. Destructive effects. Mechanical weathering may cause extensive soil erosion, which may affect agriculture. Landslides may cause havoc in mountainous areas. Chemical weathering may dissolve the soluble components of soil. This may cause the soils to become infertile and may affect farming activities. Weathering in different climatic zones. From the processes of weathering, it is clear that climate is the most important factor. For example, physical weathering is more rapid in desert climates and chemical weathering occurs in moist and cold climates. In equatorial climates, humidity and temperature are constantly high. Weathering, especially chemical weathering, is more active in these areas. In tropical climates, there is marked dry season and wet season. Differences in heating leads to consistently high rate of evaporation. During wet season, precipitation of oxides of iron and aluminium takes place from rocks. This promotes formation of laterite soil. In desert climates or deserts, mechanical weathering is most dominant due to high diurnal range of temperature. In mid-latitudes or temperate climates, the most powerful agent of weathering is the frost action. In limestone areas, solution or chemical weathering operates on a large scale. In polar climates, physical weathering due to the frost action is more prevalent. Chemical and biological weathering in these areas is negligible. The melting water of polar regions contains more carbonic acid content because carbon dioxide is more soluble at low temperatures than at high temperatures. So, chemical weathering is more active in polar regions.